As you know from first principles, the concept of differentiation came about so that we could find the instantaneous rate of change. In other words, we wanted to find a gradient at this point here. So let's just imagine that we did not have differentiation. We did not have this idea of first principles, of limits, but we needed to find the rate of change, the instantaneous rate of change at this point. The ingenious thing to do is to draw a line that is tangential to the curve at this point right here. X, Y. We're going to draw a line that is tangential to the curve at this very point. What we're going to do to find the instantaneous rate of change at this point, xy, is to merely find the gradient by counting by hand, make a very good estimate. And we do that by counting the number of steps across and the number of steps up. And we divide the number of steps up by the number of steps across. And we'd have our gradient. Now, since we have differentiation, we can easily find this by just taking the equation of the curve and just differentiating it and substituting the value of x in there, and we'd get what? The gradient at this point. Now, one of the reasons why this ingenious method, the previous method that we spoke about, would work, that is just counting the number of steps across and the number of steps up, the reason why that would work is because the gradient of the line, the gradient of the tangent, is equal to the instantaneous rate of change of the curve at that point of tangency. In other words, let me show you exactly what I mean. I am saying, if I have a curve, let's say particularly, it's the curve y equals x squared. If I have a curve and I want to find the gradient of the tangent to the curve at that point, then the instantaneous rate of change of the curve at that point would be equal to the gradient of the tangent to the curve at that point. So let's say the point here is negative 2, 4. And the curve is y equal x squared. Now, with all the information that we're able to derive from this process of differentiation, we're not only able to come up with the gradient of the tangent to the curve, but rather the entire equation of the tangent to the curve at that point. So, let's do that. Firstly, let me remind you that the equation of any line, including the tangent to a curve, or tangent of a curve, is y equals mx plus c. That's a general equation of a line, any line. Now, to find the gradient, which is m, and c is the y-intercept, we are going to differentiate the equation of the curve. So dy by dx would be equal to what? 2x, because the differential of x squared, the first derivative of x squared is 2x. Now, since we want to find the gradient at the point negative 2, 4, we are going to be substituting this x value in the gradient function, or the function, as I call it, the function of the instantaneous rate of change, right? So let's do that. We're going to be saying that x is equal to negative 2. So it will be 2 times negative 2, which would be equal to negative 4. So in other words, the equation of the curve, or rather of the line, would show a gradient of negative 4. So now let's solve for c. And to solve for c, we're not only going to be using our gradient value, but we're going to be taking our coordinate values, the negative 2, 4. So let's do that. We want to find the equation of the tangent to the line, to the curve. And all we need to do is to just substitute these values. So the general equation is y equals mx plus c. So let's substitute the values. So we have the gradient being equal to negative 4 at that point, and we have the point of tangency being negative 2, 4. So let's plug those in. So the y is 4, and that will be equal to negative 4 times negative 2 plus c. So 4 would be equal to 8 plus c. So that implies that c is equal to negative 4. So what that means then is that the equation of the tangent to the curve at the point negative 2, 4 would be y equals negative 4x minus 4. That is the equation of the tangent to the curve y equal x squared at the point negative 2, 4. Now, let's say, drawing back the same curve, redrawing that very same curve y equal x squared, let's say that we not only wanted to find we not only wanted to find information on the tangent to the curve at the point negative 2, 4. But what happened now is that there is a line. There is a line. And this line is perpendicular to the tangent. And it doesn't cut it at any point. It doesn't demonstrate or show its perpendicularness, quote unquote perpendicularness, at any point, but at the very same point of tangency. Any line that does that, we call that line the normal. So this line, this green line here, the normal, is a line that is perpendicular to the tangent and cuts the tangent at the very same point of tangency to the curve. Now, what's the relationship between the gradient of the normal and the gradient of the tangent? The relationship is that their gradients are respectively multiplicative inverses of each other. In other words, if the gradient of one is m, then the gradient of the other is negative 1 over m, rendering the product of these two gradients negative 1. So the long and short of it is this: if I multiply the gradient of the normal and the gradient of the tangent, I should get negative 1. I will get negative 1 because the gradient of the tangent is the multiplicative inverse of the gradient of the normal. So let's see if we can use this property to our advantage. So we know that the gradient of the tangent to the curve y equals x squared at the point negative 2, 4. We know that the gradient is what? Negative 4. Now, what would the gradient of the normal be? The gradient of the normal would have to be 1 over 4. Since 1 over 4 times negative 4 gives you negative 1. So now we have, let's go on another page. We have the gradient being, let's look right back on that just to make sure. We have the gradient being 1 over 4. And we have the very same x and y values, negative 2 and 4. Right? Now, let's use this information to come up with the equation of the normal. So let me write down the general equation so we can just plug it in. So we have our y value being 4. We have our gradient being 1 over 4. We have x being negative 2. And we're looking for c. So let's simplify a bit. We have that, this is negative 1 over 2 plus c, which implies that c is equal to 4.5. So the equation of the normal would be y equals x over 4 plus 4.5. And that is the equation of the normal. And you carry out that.